Yeah. Hello, guys. I'm glad that so many came here. My name is Sebastian, and I'm the leader of the WrocławJUG. I will make short introduction, and I promise it won't last long. Okay, give me a second. Okay, yes. For this, for the first thing is the situation in the world. So this is gonna be the first joke online which we are creating. So we may have some problems, so difficulties of the technical part, but we are recording this event. So no worry, we will upload everything after that. If you will have a question, it's no problem. You will just write it on the chat, and I'm gonna gather them and group them and interrupt Piotrek after some time and just ask those questions. And we all hope that you will enjoy it. We will make everything great, and let's do it. Piotrek, everything is now on your hand.
Okay, so just let me switch the screens, please. Yeah, hello everyone. I'm glad that so many of you are here with us today. I mean, we should all stay safe and stay home, but it shouldn't forbid us from learning new and awesome stuff that's happening in Java. So my name is Piotr Przybył, and this is Wrocław Java user group going live for the first time, live and online. All right. So shortly about me, I was working remotely before it became necessary and kind of popular. So I'm remote freelance software gardener. I'm also a trainer working for a few companies, one of them being Cementis. If you have some questions and comments or just you'd like to stay in touch, you can follow me or you can DM me on Twitter and on Telegram. When it comes to me, I've been working with Java since 1.3, so it's quite a few years, I would say. And I'm so deeply in with Java sometimes that even when I go on holiday, it turns out that Java is behind my back, so I can't get rid of it sometimes. All right, before we really start, caveat auditore. So let the audience be aware. Remember, it's your responsibility to doubt everything you see and try it out before going to production. So don't blame me in case something bad happens. And let's start with a question because there's Java 11 and there will be Java 17, known as the long-term support version. So many people are asking themselves a question: shall I just keep working on Java 11 and then jump to Java 17, or is it wise or reasonable to go to all these versions in between? And the short answer I can give you is, of course, it depends. When it comes to shall we be using the non-LTS version or not? You need to answer yourself a few questions and based on ask yourself a few questions, and based on these answers you should just make the decision on your own. So first, you're either going to observe this so-called support cliff because at least in theory OpenJDK is not supported, or even Oracle JDK in theory is not supported for longer than 3 months. So you either go every 6 months with a new version, or you should find yourself as someone who will act as your de facto LTS vendor. I don't know if any company will be supporting 14 for longer than that, but maybe some will, who knows. So one important thing is cloud providers. As far as I know, all these non-LTS versions, I mean non-8 or non-11, are not so popular among cloud providers. So I think if you're using cloud, it might be that all these non-LTS versions are basically not for you. And then it also means that even if there are some preview features, like in 14 we have records, for example, you won't be able to use them unless the users turn them on explicitly. and without them your program may not run. So we'll get to that. I'll explain that to you in a few minutes, but it means that preview features might not be a good option if you're just releasing your software kind of on-premise or something like that. Even if the preview feature doesn't change from one version to another, you still need to recompile it between versions, like from one version to another version. So even if there is no change, let's say in text blocks, or it didn't touch you, still you need to recompile it even if your code was working for Java 13, for example. And there are also some obvious benefits, like you can benefit from better performance, from better GCs. I mean, stuff that is not backported often, or it's not backported instantly. For example, many companies decided to go to Java 9 right away without waiting for Java 11 because they wanted to benefit from compact strings to save, tons of money on heap spaces, on RAM and cloud and so on. And it also means better feedback for the Java team because de facto all the features are now preview features for 2 releases. Because one release would mean actually 3 months, so it's not enough. So that's why they decided that everything will go, as far as I can tell, by 2 releases when it comes to preview features. So based on that, they have not 3 months, but 9 months of getting feedback. So that's important. So if you have, you can give it a spin, you can give it a try, and if you like it or you don't like it, you can just, shout out your feedback or send it to the architect of Java. I think they will be happy. And there's one more thing. It's eating the elephant in small pieces, because there's a joke in Polish, how to eat an elephant, and the answer is piece by piece. So jumping from Java 11 to Java 17, just making like one huge jump might be difficult. So if you're not bound by cloud providers, like maybe you're running everything in-house, maybe it would make sense to just take care of your product and migrate it from version to version in order to avoid this huge jump after 6 releases or 3 years. Okay, but there's one thing we should remember, that neither non-LTS releases or the preview features are so-called monkey soft or banana soft. As far as I can tell, they're like, they are subject to change. I mean, the preview features are subject to change, but it's not that they come untested or that they will throw random exceptions and stuff like that. They are like taken care of. They should be working properly. It's just there is no promise that this is carved in stone and this is exactly what you will see in every version of Java from now on. So let's talk briefly about Java 14, which was released yesterday. It was like more or less 24 hours ago. So it has 16 JEPs in total, which combined is more than Java 12 and 13. I mean, Java 12 and 13 together didn't have that many JEPs. And actually, when it comes to Java 12 and 13, I was given a deep dive at Devox in Belgium, and it took 2.5 hours. So we have more JEPs for Java 14. So maybe you should get prepared. I'm kidding, we're not going to take it for that long, I hope. So these are release notes. The slides are online, slides are available, so we can get the links, like for the JEPs, for the release notes. And there is a new syntax. I mean, switch expressions are normal preview feature. They are just standard feature, standard part of the language syntax, so you can use them from now on. There are some preview features. Multi-line strings are still kept as preview, and we have pattern matching and records. And we also have 2 incubator modules, one being for memory access, and the other one is packaging tools for native platforms. So this is, I believe, 8 of the JEPs, and here are the other JEPs. So we've discussed them through, as you can see, and the thing is done. Of course not. We'll discuss these JEPs one by one. So switch expressions. And now they are standard feature. This is JEP 369, and they were introduced in 12. They got slightly updated in Java 13. I mean, the break was replaced by yield, and now in Java 14 we see them as standard feature. A short recap before we go further, the difference between statement and expression. So this is a statement in Java, and for example, if is a statement. So as you can see, this is a variable, and here we are, if true happens, we assign a value of 12, and if false happens, we assign a value of 17. And as you can see, statements are relying of the side effects, because what's this and this is actually a side effect. So I'm changing a value declared somewhere else, whereas so-called ternary operator is actually an expression, or pretty much an expression. See, based on this, I either yield 12 or I yield 17, and this is the value I get, so it could be declared as final, and I'm not mutating it, so there are no side effects. Okay, and I couldn't resist. I mean, being also a Scala fanboy, I couldn't resist. So this is it. You see, in Scala, everything is an expression, including if. So that's why Scala doesn't have ternary expression, because if is an expression. So you can do it this way. So these are the switch statements we all know, like switch statements in Java 11, 12, and so on are still okay, still valid. I mean, the code will compile, you can use them. It's not that switch expressions will replace switch statements. So this is it, you know, like based on the number, or sorry, the end of the day, we are going to say how many lessons we have, basically. So here, for example, we have a case of with the fallback. So for Wednesday and Thursday, we have 2 cases, and then we have 8 lessons and so on. I mean, not rocket science, we know it. And now, since Java 13, we have this yield. Previously, we had break, and this is also the valid syntax of Java 14. So in case of Monday, Friday, we're going to yield 6 and so on. So this looks pretty much similar. Please notice this return here in front of this switch. So we are returning the value yielded by this switch, just as it was provided. And yeah, this is also another syntax option. It looks more like a lambda, and yeah, I think it was made that way to be similar to lambda. So see, it's more concise. There are no breaks or yields or fancy stuff like that. We just say for Monday, Friday, just yield 6, and that's it. Yes. We need to remember that switch expressions must be exhaustive. So, for example, this won't compile. Maybe I switch to sources. I mean, everybody, I guess, prefers to see that, provided it will work. Sorry, Sebastian. I need to switch to the window. Yeah, so here it is. Okay, so here we have switch expressions and the lessons checker. Here it is. So as you can see, there's a simple program, and we have various options of switch expressions. So let's run it and see, sorry, how it works. Okay, so it says, hello Java 14, and I have no lessons because we didn't give any argument to it. Because the main method is like looking for arguments, so it's I have no lessons. But we could give it an argument. Let's try, let's say here it's Wednesday. I hope I didn't make a typo. Let's see. See, so on Wednesday I have 8 lessons. This is how it works basically. So we're using this, how many lessons I have with arrow, and this is this lambda style approach to switch expressions. See, I'm returning basically this value. And we could also have lessons, this lambda style, but with blocks, pretty much like we have with lambdas. Let's say you need to have a side effect. I mean, I wouldn't encourage you to do it this way, but still it's possible. Yeah, arrow blocks. Okay, let's run it again. The code is on GitHub, so you can run it freely later if you find something confusing or if you don't catch up, because I'm going to kind of go briefly through these switch expressions and also text blocks, because we've already covered them during the previous session of WrocławJUG and also Devox Belgium. So we'll put the links to the description if you need to get a more detailed description. So you see, in this syntax, you can also have these blocks, and this is the instructions. We know. See, this approach shows the default through. Basically, so for this old switch statements, and here with this yield approach, we also have fall through. So let's go for this approach. Let's replace it and run again. And of course, we have this side effect, pourquoi mercredi, in here. So as you can see, with yield and not this lambda style, arrow style, you also can have fall through. So I'm not quite sure if it's a good approach. I think you shouldn't be doing this. If I were to, just get a rule of thumb, I would always do switch expressions like this. If you desperately need to, maybe like this, but I wouldn't do them in a way similar to switch statements, so they look like this. So if you see yield, if I would see yield, I wouldn't say it's quite okay. Yeah, let's go further maybe with the code. You see the switch expressions need to be exhaustive. If you do some, yeah,
there is a request. Could you turn on presentation mode?
I would rather not. I mean, I can make it bigger. I think it's okay, because I'm a little bit confused with the lights, the camera, and adding presentation mode to that would be maybe too much. So I hope, guys, you don't mind. I think this is quite readable now. Are there any other questions or requests? Or
No,
critiques,
for
maybe?
now, no. People are asking about why the background on your ID.
So is it not okay that is white?
No, it's okay, but why?
For the presentation, of course. Normally I have the dark mode enabled. Come on, let's have some respect. But it's a presentation, I'm doing stuff, so I thought it would be better, to have it in white. So normally it's black fault, so don't worry. I'm not that weird. Anyway, as you can see, we have this switch expression in here, and it needs to be exhaustive. If I don't have the default, like in here, the compiler is not going to accept this. So see, this is a clear indication of the need of exhaustiveness of switch expressions. Okay. One thing that doesn't work from switch expressions is returning. So see here, I'm just adding 1 to the input. Here I'm as default I'm returning -1, and here for 3, 4, and 5 I'm going to double it, and I can't just return it and kind of jump out of the method. It's not going to work, so I can't do that basically. I just can yield this this value outside, so this return doesn't work. So let's comment it again so the compiler doesn't cry. But return from the switch statement keeps working, and that might be a bit confusing, because you see this old Java 11 style, or let's say Java always style, also can be written now using these arrows. So I can go down here to these arrows, and you see now I can return, because this is not a switch expression, it's a switch statement. So now you can also write switch statements using arrows. It's just they're not expressions. I know it's a bit confusing, but what can I do? I can't tell you for sure why it was made this way. Maybe it was for like easier migration for ID support or something. Personally, I would always do switch expressions with arrow without fall through, and I will always do, if I have to, the switch statements. I would do them the old way. I wouldn't do this way because this is a mixture basically. So I have like a switch statement only with no fall through. And see, when I try to add a return in here, suddenly it doesn't work because I turned the switch statement into switch expression, and returns in switch expression are banned. So I would have to yield to make it work. So please be careful when using the new syntax and stick to a style. This is my recommendation. Yeah, and if you use switch statements, see, they need to be exhaustive as well. If they are not, the compiler will complain basically. So sorry, it should have been of course switch expression. I made a mistake. I made a mistake in here. Should be switch expression. Sorry. And there's one more thing which might be important, is that switch does not need an assigned type. Let's run it, and you can put your bets in comments. We'll see later who was right and who wasn't. So let's comment this, and let's put this call, and let's go back to the code, and please tell me what it will print. I mean, you don't have to tell me, just, you know, put a note in a comment. I mean, don't do randoms like this because of the seed, and initialization is demo only. So we can now switch on this input, and if it's like 0 up to 4, we'll yield a string, a very small string. And in all other cases, we will yield just what we got. So let's run this a few times. So now you see I'm very small, and it's a Java string. And now it's also string. Oh, sorry, it was integer. I just missed that. Sorry. Now we have it again. See, it's the class of 8 is Java lang integer, of course. So you can mix and yield apples and I don't know, plums, or whatever you return with apples in English. You can just mix them. I'm not sure if it's good. I'm sure if it's correct. Maybe it is. Maybe it isn't. It's possible, and that's why this var type indicator is very handy sometimes, because then we would also would need to say it like make it object or make it serializable. Because of course making this string doesn't work in here because we're yielding integer, and making this an integer doesn't work as well because I'm very small. It's not an integer. So we can go like object, as you can see, then it's okay. Of course, because everything in Java is an object, or it can even go serializable, or it can go more with this, crosscut types, or whatever it's called. Okay, let's go back to, var. So this is it. I mean, this is how you can use switch expressions. I would really recommend to state that this style, if you desperately need, I don't know, some logging or something, maybe this is the style. But I would recommend using it with arrow, not just going with these yields with columns, because as you saw here, it's still fall through. So I would say too much C++ in these days, if it's not C++, of course. Okay, back to the slides. Sorry, let me find the slides. Come on. Where are the slides? Yeah, okay, we have the slides now. So yeah, it's more lambda style, no fall through. So blocks are still possible, and return is not allowed in switch expression, but it's still possible in switch statements. And switch expressions don't define their types. And there are plans to evolve this toward pattern matching with deconstructors and stuff. So there's a very nice article. I recommend you should read it. And this could be very useful in the future with records, because it is said that records could have very nice deconstructors. Yeah, these two features combined with switch expressions could work very efficiently. I mean, if you know any functional programming you should be at home. And now, before we talk about any other features, I'd like to recap briefly what a preview feature is and how to enable it. I mean, we've discussed what it is, but how to enable it, how to see it, how to give it a try, basically. So these are implementation of JAP 12, and basically they are about enabling them. So this is this flag, enable preview, and you add this flag. Okay, yeah. It's not about cherry picking. Let's say if a Java version has 2 or even more preview features, like we have records, we have text blocks, and we have pattern matching with instance of, you can't select just one. It's either all or nothing. You can't go please give me one and skip the rest, or vice versa. It's everything or nothing. And versions must match. So the version of the feature must match the version of the compiler and the JVM, meaning if something is a preview feature, like let's say switch expressions were a preview feature in Java 12, so you can't compile them using Java 13 unless you're using the syntax that is also okay for Java 13. But then when you run them and they were compiled as Java feature, they also need to be running exactly using exactly the same version of JVM. Okay, so just use enable preview flag for Java, Java-C, JShell. You can also need to add that to build Gradle, to POM, and in your IDE. Okay, so this is how it works. For Java-C, you need to set enable preview and then release and 14 if we're talking about 14. And release is de facto like setting source and target combined. So instead of setting source and target, you can just set the release and that's it, you're done. So it's release or source is mandatory with enable preview. You just can't enable preview for Java compiler without saying for which version you're going to enable it. And it emits a warning which can be disabled, and it's written into the .class file, as we'll see in a minute. So I'm not sure if I'm going to run these demos. I mean, we've done them there from the previous meetings of WrocławJUG and also DevOps Belgium. So we'll just go through them quickly. As you can see, when I have this Java -- enable preview -- source 14, and then I try to compile this source file, this is how it works. So then there's this warning emitted which cannot be stopped. It says it uses preview language features, and then there's of course that the preview, so I can see exactly which preview feature was used. And then there's a regular output. Sorry, it's not only Java-C, it's also Java when I'm using it with .java file, because as you know, with Java we can now run single file programs without compiling, so you can do it as that just as Java. Okay, so you see, when I try to compile this very same file and I didn't add enable preview, the compiler just won't see. This is a text blocks, so text blocks are preview features, so we need to add preview feature parameter to Java-C. So when we add it, it still complains because it must be used together with source or release. So we say exactly that it's Java 14, and you can't set anything else for Java-C version 14 because it can't compile the preview features of 14, obvious. But it also can't compile the preview features of 12 or 13 and stuff like that. So it has to match exactly the version of the compiler. And when we do it like this, you see the warning emitted again. First, this warning that is that preview features are used, and then that you can recompile with this xlint preview to see exactly which features were and so on if you really wish to. Okay, and then when we try to run this class file, I mean, in this previous slide we got, as you know, from compiling with Java-C, from compiling a Java file, we get a .class file, and if when we try to run this .class file using just Java, again it will complain that you need to enable them explicitly, not only during compilation time but also during runtime. So see, try running with enable preview to make it run. I mean this class. Okay, so we can do that, and when you enable preview, then you can run this program, and here's the output again. Don't worry if you don't understand the output when you're not Polish. because it's written in Polish. So a little experiment, you can check which version of JavaC you have. So I had JavaC in version 14 and also Java in version 14. Then I switched to Java 15 to early access of Java 15 OpenJDK, I mean, and see, then I had Java in version 15. And when I tried to run this using Java 15, I mean this class file I generated in previous step, then even when I say Java and enable preview and this class, it doesn't work. Why it doesn't work? Because the version inside this class file says it's 58 something something something, and this Java can only run preview features of version 59 something something something. So this is we need to do a quick math. So this is 44 plus the version of Java, of course, and for regular class files, if you don't use preview features, it's .0. But sorry, when you use preview feature, the compiler sets it as 2 to 16 or something like this, and then therefore it's like a message from compiler to the runtime. Look, it's going to use preview features, so they need to be enabled explicitly by the user, and they need to match exactly the Java runtime version. This is, this double equals from one of the previous slides. All right, so to set that in Gradle, you need to set compile arguments to add enable preview, and also for us, if you're running them as tests, you need to enable them, and if you're running your application, you also need to add them, and so on. I mean, once they work, because I've checked that a few days ago and Gradle still wasn't supporting Java 14. Maybe it changed during the last few days, maybe it didn't, I can't tell. That's why today's examples are done using Maven. And in Maven you do it this way. So you say as compiler arguments, you add enable preview, as in here. For Surefire plugin for running tests, you also need to enable preview, and so on. I mean, everywhere, if you start using preview features, the compilation and every runtime needs to know that you enabled these preview features. And in IDE, setting that in IDE is also quite simple. You see, you go to the project settings. I try to go to project settings. You go here to project settings, and you can choose, the language level. Let's say I have here 14 for as a preview for Java. For these records, for this demo. And one thing that might be important if you use it with, for example, Gradle, is just sometimes you set this as a project level, because IntelliJ can't read it from Gradle that you're going to use preview features. That's why you set it in here in preview, and then you need to also set it in modules. And then you can click OK, and then you can compile and run, and stuff will run until you re-import the project from Gradle, because then you need to repeat these steps. So in case you're using Gradle, just double check it. I mean, maybe it got fixed for Java 13 and Gradle version at that time and an IntelliJ version of that time, it didn't work. One also important thing I like to show is just if you're running IntelliJ and you don't have Java 14 installed, it's really simple now. So we can just go to, not edit, but let's go again. Sorry, it was SDKs, and you can click add, and now you can, you can go to download JDK, and it will download Java 14 for you if you decide. See, this is the window it shows up if you're not running slides in presentation mode, and you can just download it from OpenJDK and then save it in here. So it's really simple. You don't have to even use SDK Manager, as it seems, for IntelliJ. Okay, yeah. So let's get to first of the preview features. I mean, this is the text blocks, and they are still preview feature in Java 14. They were introduced in Java 13. As far as I can tell, everything that was running as text block in Java 13 will also continue to work as text blocks in Java 14, only now you can do more with text blocks, and this is Java 3.6.8. So this is an example of defining strings we know in like Java 11 and 12 and stuff. So if you have like multi-line string, you just have one line, you need to add \n and so on and so on, and it doesn't look that bad. But if you need to do more escaping, like add tabs or this escape like quotation marks and stuff, you see then generating this simple JSONish string may start looking ugly. So, I mean, you can also have like SQL queries and so on. So they look pretty ugly, and the purpose of string blocks or text blocks is to make them less ugly. So we can define this poem like this. You can open it with 3 quotation marks. Sorry. Then hit enter. Then you can enter your lines line by one, and then you can quit with 3 quotation marks anywhere, basically. And this is even nicer for like JSON, for example. See, I don't need any escaping here for this very example. One thing, don't worry about the colors. Everything should be also in this, whatever color it is. It's just this JavaScript plugin doesn't recognize this. This new syntax. So don't worry about this. It looks okay in IntelliJ. So when we go back to IntelliJ, we should have text blocks. Here they are, text blocks. See? So we have text blocks. Let me go to the top. Let's run this example. So you see I'm not lying. Maybe I'll make it smaller. Yeah, maybe like this. See, and it's now we get the whole poem, and we had this JSON describing it twice. So this was this ordinary string, and I make it bigger. And this is a text block, and this is the ordinary string, and this is text block. So see, this compared to this, it's much nicer. And if you have longer strings like this, it's also looking okay. But let me uncomment these. So we run them, and we'll walk them through one by one. Okay, let's run it again. Okay, because I'm going to describe you the indentation and, you know, other stuff. So let's say you have this get lorem ipsum, and this is one of the changes that were made in Java 14. It's like when you have this lorem ipsum, these, you know, these, see, I have space here and a space here and a space here, but when I tried to make them as a text block, they got wiped away because these are called accidental white spaces or something like this. And basically, when you have trailing white spaces, they get cut off. So when we were trying in this call, see, we were trying to replace all line endings with nothing. So maybe I'll comment it for time being, so you see what I mean. All, yeah, let's run this. See, so this is the block. So this is the block, and when we take a look here, it doesn't have this space. I can't select it. It doesn't get selected. See, so the spaces at the end of the line get chopped off. And when we try to make it a single line in this naive approach, which you shouldn't follow, then look what happens. This space is not preserved in any way, of course. So that's why this and these differ in length. And you see, for example, here we don't have this space, whereas here it is preserved. So now in this lorem ipsum one line, we can use the new syntax from Java 14. So you can add a backslash, and it means don't add a new line in here, basically. And this space will be preserved, and everything, as you can see, is returned as a single line, and these spaces are preserved. So if you like to have multi-line string, single line string in a text block, this is the way you go. You just add backslashes at the ends of the lines. And when you would like to have, of course, backslashes in just more than once, like in this cows, we can have a nice example of American cow and Polish cow and an Australian cow. You see that when you'd like to have a backslash, you need to escape it. So if you like to have something like this, it needs to be escaped. That's why it doesn't look so nice Remember, text blocks are not raw strings, so this needs to be escaped. And if you'd like to keep a space is here, so this line is not like cleared, because I can delete this and also maybe we can comment out these lorem ipsums. Let's run this. You will see what happens here. What happens here, see, is like I have this line. After this, I have, and this is the line's endings basically in here. And the line, this line is empty. I mean, there is no character. And let's say I wanted to have a few spaces in here because whatever. So to have these lines in here, I need to add \s and \s, which basically adds an empty space and means that all these spaces and this trailing space should not be removed. So now see, there is this space added. Sorry, so yeah, this space is preserved and the others are chopped off. I mean, these ones I'll show you why, but now you can have at least a single space in this line. We'll learn in a minute why these are removed. And again, this escaping, if you like to see a nice cow town like in here, you just can't copy and paste. It needs to be escaped, but when you're copying from some external sources, IntelliJ will handle that for you, so no worries. Okay, and let's make this, let's comment out these cows, and let's make this indentation test so we can understand why these spaces got chopped off. So see, this is the way, let's say indentation tests. Yeah, so these are the ways you can't declare text block. It doesn't compile because it doesn't have a new line after opening. You need to enter a new line here. So it has always this syntax, quotation marks, yeah, and then a new line to make it work. And this one won't compile as well because it doesn't have this close-in, you know, three quotation marks basically. So it would need to have something like this to make it work. If it doesn't, you see it's still green in here. So it's not closed in a valid way. So if you'd like to have 3 quotation marks, this is the way for you to go. You need to escape any of them. Like it can be the first, the second, or the third. I would always go with the third, but it's like a matter of the taste. See, let's go in here. It has 3 quotation marks. See, so if you need to print 3 or more, you just need to escape some of them. Like it's illegal to have 3 consecutive quotation marks. And this is not indented. See, it has no indentation, and this has no indentation, and also this one has no indentation, these examples. And we could do it like this, or I can add a tab here, like even a few tabs. Let's run it again. And they're not indented. See, either. And now let's make them equal. Like, okay, like I will add 2 tabs here and 2 tabs here, and I will pay, sorry, this 1, 2, 3 spaces, 1, 2, 3, and let's run it again. And see, it's still not indented. So the reason is that the position of this matters. If I'd like to have this indented, I would need to make it like this. You see, now the indentation is kept here. Or we could do it like this and run it again. Oh, I think the formatter messed up the source examples. I will, you know, make a comment fixing them. But see, this is how it works. So this is indented by 3 spaces. Let's make it bigger. 1, 2. Sorry, it should be this indent. I just lost count. Which indentation is this? It might be this one. Or this one. Okay, how it basically works is this. Yeah, you can of course have empty lines between and at the end. See, and these are preserved. We have 1 empty line here, 2 empty lines here, or more empty lines here. And now let's run this example. Yeah, and you might be worrying like at this and this. its tabs and add 2 more and 2 more, because I'd like to explain to you how it works. Spaces, and let's cut this one. Yeah, so I think, yeah, this is a problem. It replaces spaces with tabs. I would need to keep this. Let me scroll back this and tabs to spaces, to spaces to tabs. Or let me just add tab and tab and tab, and let's see now. Tabs and here and here, because the way the indentation works is this. It basically counts all the white space characters in the front of the line, and if all of them are white space like this, they get chopped out. So it's like this and like this, and actually it happens from the front side. So the compiler keeps chopping off white characters, and if I had tabs in here, you could see that this would jump much forward, and then when the first line has no more white spaces and we are excluding lines which are totally empty, it would mean that we've reached the end of this of consuming this indentation, and therefore the stripping of the let me call them front spaces is over, and that's why it works like this. That's why this is not indented, because it matches this. See, so all these spaces get consumed like this, more or less, and they consumed equally. And this is indented because in these two lines, see, I'm consuming, and here the consumption ends. And still we have these, here is a tab. So we have this tab, and that's why this is indented by this tab in here. And beside that, text blocks, once you create them, behave like every other string. So you see, I have one text block, and I can concatenate it with another block. So I have this NA and DUA here, and also there is a new method with since Java 13, just like string format, only it's formatted. And you see, I can just declare this string, and then I can format it and run it. So this is the way to use text blocks. I mean, you can use them for maybe some JSON, maybe some SQL queries and stuff like that if you need to. So let's get back to slides. Yeah, so opened by 3 quotation marks, closed by 3 quotation marks anywhere. I mean, this could be the same line, or it could be a different line. Position of these quotation marks matters because of the indentation. I mean, if you have this as a new line, then it also counts as a line which has to be taken care of if in this indentation calculation. And once created, they can be used just as any other string. Yeah, so this is the example. Sorry, let me go back. Yeah, and at least one line. This is the description of this indentation process. At least one line needs to have no indentation. And so where's the left? Your left. Here's the left. Or maybe I'm sorry. It's like yeah. Here's your left. So all lines are checked against the if they begin with spaces. If all of them begin with space, then this front space is chopped, or white space character, because tabulator and space count just as one. And then there's another one, another one, another one, another one, and so on, until it finds, or when it finally finds a non-white space character, then this whole indentation process stops. And empty lines are not taken into account in this process, and all trading spaces get removed unless you have this backslash or backslash space. And all white space characters are counted equally. I mean, it doesn't matter if, because of these endless frameworks, like I should display a tab as 2 spaces, 4 spaces, 8 spaces. So the architects of Java decided that every white space character counts just as 1. So it doesn't matter if it's a tab or space, it's always 1. Yeah, you can have empty lines. And
there is a question.
Yeah, there's a question.
Asking there is any placeholders possible in multi-line string.
Placeholders. I'm not sure if I get the question, but I mean, if you're going to format it later like this, and if it's considered as a placeholder, yes, it is, but they are not interpreted like in Scala. If you mean something like this, or like this Scala syntax, like so I can have like int I equal 12, for example. I can't do anything like this, or I can't do anything like this. They are not interpreted. This is not Scala. Okay. I guess this is the question. So the answer is no, it's not possible. Any placeholders like this are not possible. They're not going to work. The only way, as far as I can tell, to do that is to use string format or dot formatted since Java 13. So this is the way. Of course, with all these switches, and you can use like %d and stuff like in here, %d or %s for strings and so on. But any other placeholders are not allowed. Any more questions?
No, nothing.
Nothing for now. Thanks for being my angel, Sebastian.
No
Okay, so yeah, this \space simply inserts a space, just one space, with code 32, and this keeps the new line, so you can enter just one huge line and just chop it between lines in your editor. And this is a JEP and a place where you can find this new stuff, how it works if you'd like to play with this more. However, so text blocks are simply strings only without need for explicit white spaces, and escaping works the same way. Like I have shown you with like double backspaces, and the concatenation works the same way, and so on. And blocks are no raw strings literals. There was a feature that was merged into one of the builds or few builds of Java 12, but finally they didn't make it. They were supposed to start with this opposite apostrophe or whatever it's called in English, but they didn't make it. So some say it's good, some say it's bad. Some people don't care. Choose your option, choose your mood. And there's a nice article, Programmer's Guide to Text Blocks, how they work. If you like to learn more about this indentation, either read this article or just go back to one of the videos we had previously. And let's go now to pattern magic for instance of. Okay, so it's a preview feature introduced in Java 14, JEP 305. We know this code, right? We know this code. If object is instance of integer, then cast it to integer to have it like that on integer, and then just double it. And it's some say it's Java is so verbose and so full of ceremony that maybe it's not needed. So now in Java 14, if you enable preview features, you can do something like this. You can say explicitly it's an integer in here, and then in this scope it's just an integer with this name. So you don't need this line basically. So there is more. Let's go to pattern matching. So we have this pattern matching. You see, this is an example of pattern matching. So I get an object, and if it's serializable, I'm saying it's serializable. If it's a string and it's longer than 2 characters, then I'm gonna print it's a string, at least 3 characters long. If it's an integer and it's a positive one, a positive integer, and then if it's a long and it's between -8 and +8, then not between, exclusive, of course. If it's -10 or less, or if it's 10 or more, then I'm going to say you're long with at least 2 digits. See, so these are various arguments in here. Let's give it a spin and see how it works. Yeah, so it's a serializable, instantly serializable. Then it's a string which is not long enough, and see, I mean, I don't need this bloody casting. It's gone. And what's also important, if you have this, if you have this and shortcut, you see, I have declared string in here. So that's why I can use it here. I don't need this nested ifs or something like this. I can just do it as a nice one-liner now. So this is the introduction to pattern matching with instance of in Java 14. Pattern matching is not only about this, as I have told you. There will be some distractors most probably in the future to be more like maybe functional programming oriented and stuff, but this is like the first step to pattern matching. And there's one thing I'd like to tell you is just please make sure you implement equals in the right way, because if you do something like this, remember that so I have this point class, which is like a flat, just 2 dimensions, and I have 3D point with 3 dimensions, and I have this class, and then I do this point 3D extending it, which is not using the inheritance properly, basically, because yeah, it's of the Liskov substitution principle. Then if because many people are tempted to use this instance of here, just not to compare classes, but use this instance of here, so it's that point and equals. So when we run this example, you will see, okay, you will see first through and then false, which means that these points are not equal to each other in a symmetric way, which is bad. I mean, sometimes you need to write equals like that for GPA, for example, for some dynamic proxies and stuff. But when you have just POJOs, which are not persistent and stuff, this is not, or domain object. This is not the way you should write equals. So please be aware when you are creating something like this in equals. I think equals is not a good place to do that stuff, or at least not always. Just please keep that in mind. So I don't need to do a code review of such code too often. Okay, so records. I believe many of you came here for records. So these are also preview feature, and they were introduced in Java 14 or are introduced, and this is JET 359. So there is a record is actually a new kind of type declaration, and record is a restricted form of a class. And this is how it can look like. We say record, so it looks pretty similar to case class in Scala, or also to some other constructs. And then we enter like the first component, which is real, and then the second component, which is imaginary, and that's pretty much it. I don't need to do anything else and nothing more to declare this record. So all fields become private and final. So it's shallow in immutability, because if you have like mutable fields, you can mutate them inside. I don't think it's a good way to use records, but still it's technically possible. So all these fields become private final. Records also generate constructors, accessors, equals, hash code, and toStrings. So we don't need to generate this boilerplate code or use Lombok's value, for example. But we still can write these implementations, for these methods on our own if we need to. For example, you need to obfuscate something into string, maybe, I don't know, in GDPR and stuff, for example. And there are 3 kinds of constructors: compact, canonical, and custom, and they can implement interfaces. So these are the things they can do, not all of them, but I think the most important ones. Okay, sorry, and they have custom instance and static methods, so you can also add other methods to records, for example, if you feel fancy, because why not? What they can't do is that they cannot extend classes, or they cannot be extended. Pretty much like enums. You cannot extend an enum, and your enum cannot extend another class. I mean, it's always extending enum, and that's it. And so applies to records. They always extend record, and that's it. You can't add anything to this inheritance tree. They don't have setters, and they don't have getters, my friends. This might be most shocking to many people, because Of course, all these fields are private finals, so the setters are not generated. But then for these fields, the methods generated for these fields are not called getters, but accessors. We'll get to that in a minute. And you can't add extra instance fields. I mean, everything has to be declared in this, let's call it the signature of the record, although it's not technically correct to say that. Okay, so let's go back to code, because words are cheap. Let's take a look in the code. So we have this complex number. See, it's real and it has imaginary, so 2 parts, and I can have methods like add, subtract, the other, and then I'm creating a new complex number, and they can also multiply them, and I can also have this toString method. So I have this hello records, and I'm going to run this example. Okay, so we see I had 2 complex numbers, Z1 and Z2, and I can multiply them, and also I can have just a complex 1 and print it. So as you can see, I can call it a record. That's why record is not a keyword, but I can't call it an enum. So enum is a keyword, record is not a keyword. Remember this. Record. I'm not sure if it's useful anywhere beside this, recruitment interviews when they are screening if you have a compiler in your head, but still, maybe it will be valid for someone. Okay, so this is the way they're printed out because I said so, because I decided to override this toString method. If we get rid of this method, we'll see the default output, which is like this. So this is the simple name of the class, and then every component is printed out with this with its value. And we also have other stuff. So yeah, let's go to basics. So we have valid records examples. Right. So a record doesn't need a field. We can have record with 1 field. And we can have records with custom methods. See, here it is, a record with custom method, which can say print hello. I mean, I think it's not wise to use it this way, but still it's possible, as you can see. And also records can have static members. I can declare a static field for, which is always bar. This is mutable, so it could be, because it's not final, as you can see. Fields are mutable in terms that, fields are immutable. Sorry, let me put it otherwise. Fields are final, but if you put as a field something that is mutable, just like atomic integer, it can mutate. You see, I can have this bump method, which can increment the value before getting it. Maybe I should run this example so we can see how it works. See, so we have this no field, 1 field. We have this hello stranger custom method. We are just barring for this foo. We are bumping. So see, we are bumping 3 times here at the top. See, bump, 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 and we're printing this out. And then we get the value for this counter in here. So that's why we have 1, 2, 3, and then 3 again. I can override the toString method. See, I can say instead of like this 1 field or no field, I can say howdy, it's a nice day, and blah blah blah, yada yada yada. And then I can also generate equals and hash code on my own if I decide that the default ones are not okay, but I'm not sure why would you do that. Still, it's possible. You can also have custom accessors, and as you can see, this has no get prefix. So records are POJOs, but they are not following Java Bean convention. So they don't have setters because all the fields are final, but also they don't have getters. They have accessors. Difference. Okay, so when I'm accessing this secret, I can just have a side effect. Also, not a good approach, and don't do that. It's just demo. Don't do anything fancy with the stuff somebody's trying to access. I mean, maybe sometimes you need to log it or stuff, but please don't don't do that on the fly or whatever. Just follow the convention, please. So yeah, so this is this. Please don't tell anybody, and it's 777. And now we can have constructors, because see, this syntax generates constructors, and we can have canonical, compact, and custom constructors. So this is the canonical constructor with every field possible, and it's grayed out. So I think IntelliJ wants to tell me that it's not needed. And sometimes you'd like to override the constructor, even such one, because you'd like to, for example, do some asserts. But if you do so, you need to then set the value of the fields, because if we don't, then it's complaining here. Pretty much like if we had this final field. It says record component might not be initialized in canonical constructor. Okay. So I need to assign every possible field in this canonical constructor. And I can also have compact constructor, because this is boilerplate and this is boilerplate, and everything I want to do is this asserts. So just to have this asserts and this system out, I can get rid of this argument list, and then it's called compact constructor. And if I really need to, I can go the in-between way. I mean, let's say you have a custom non-canonical constructor record with 2 integers, length and hash, and then we pass it a string, and then we initialize this these fields with length and the hash code. I mean, I don't know why would you need to do that, but technically it's possible. And as you can see, we need to call this. If I skip it, it's going to complain again that these fields are not initialized. And of course, we can't name this field hash code, because then there's a clash with this hash code method generated by default. And of course, they can implement interfaces. So for example, I can implement comparable. So these 2 records, all instances of this record can be comparable, because why not? They can be, also other interfaces implemented. Things you cannot do are here in these limitations. So let's go into these limitations. So you see, they cannot extend. You cannot extend the class. Record cannot extend the class. And you can have a class extending a record. It's also illegal. You can't add extra fields like in here. So you have kind of a, you want to have these accessors generated for these and have something extra private like in here. It doesn't going to work. It's not going to work. And also you can have the setters, because this is a final field. So we can't assign a value in here. Okay, let's try to go back to the slides. Yeah, so when it comes to reflection, there is a new method in class. It's record, and you can also get the record components. Because they're not fields, they're called components, and you can just look in, as you can check if something is an enum. You can also check if it's a record. But yeah, let's go to this extend reflection. Yeah, so we have this reflection. So I have here is demo code. So I have an enum and I have a record object. It's like declared somewhere, and I'm checking if this is an enum and if this is an object. As you can see, I get the class and its enum is record, so it's pretty much similar. And then I can get record components of this record object, and I can investigate the contents for each content I get here. So let's run this code. I know I'm going pretty fast, but really there's, as you can see by the code, there's still a lot to cover. So maybe later you can just pause the video if you really need to, or just to watch the parts again, or ask me a question so I can explain it in a more peaceful manner. So it's an enum true, a record true, and of course this method describes. I get the value by reflection. Like see, I get the accessor and then I get invoke on this. So I get the value from this object, value for this record component, and I also get like see the component A is of type integer and belongs to this record, and it has this value. And the same for the second field. It's B, which is string in this reflection check and has value call me maybe. And thing is, when we try to use this description of bean properties, you get this bean info from inspector get bean info, and we're trying to follow this Java bean convention. Then look what happens. Properties so we have these. These are the properties of this reflection check record. So there's only one property in terms of Java bean, and it's the class. You see, it's the method get class in here, and there are no other properties. So these fields or these components are not properties in terms of Java beans. And when I do it when I do something resembling as an ordinary Java bean, as you can see, I can have this UUID, or I can have string, because I can have this bean with setters. Like it here, I have bean with setters, and I have getters and a setter for this mutable field, and so on. So it's different. So I suspect there might be quite a few issues with libraries, frameworks, and so on, because records are not Java beans, my friends. Keep that in mind. Okay, so serialization of records. And the nice thing about serialization, actually deserialization of records, is that the constructor is used to recreate them again. And maybe some libraries and frameworks will need to adapt to that as well. I mean, it's not a rocket science, but not reflection, serialization. Here, see? So I'm trying to serialize, let's run it, because why not? Yeah, I'm still running a serialization. I mean, this binary format used by Java JVM, so I'm not serializing to XML and JSON and stuff, so it's the binary stuff. And I'm going to serialize serialization record check. So this record looks like this. It has just one field, which is string. And I'm also going to serialize the bean, which also has just one string. And see, I'm serializing it, and then I can examine the bytes. And so we are creating the record here in this constructor, because this is the constructor. This is what it says. We're creating record. So we are storing these bytes basically. And when I'm deserializing this object, then, as you can see by this line, the constructor is called again, right? And I have deserialized this record in here. And this is different from just ordinary Java beans, because you see, when I'm deserializing an object, which is not a record, then the constructor is not called, which is a bit different. And again, is it good or bad? I leave it to you to judge, but interesting things happen when we try to use, for example, Jackson, and we'd like to serialize. These objects. Yeah. So let me comment out this and run this. Sorry, and system out. Yeah, it was missing. Okay, let's run this. And I'm asking Jackson to serialize this record. And see, it complains because it fails on empty bins by default. But we could say, why? It's not empty, it has this string field, right? I mean, when I do something like this, not this, for this bean, it also doesn't work because it has no serialization, but we're creating bean for bean. Let me go just here. Yeah, because it's not a bin. Now it is a bin. Am I right? Yeah, because it has this getter. So when we run it like this, it's going to work. So I have this just one field with value bin. So when it's a bin, when I have this getter, like we do every day, then it's going to work okay. If I don't have it and I have the accessor like this, then I need to add this bin property, right? So when I run this example now, you see then it's serialized again the same way. But the records don't have the getters. So when we try to serialize them, as for example, or Jackson, we try to serialize them. Let's run it and see what happens. It's exactly the same. It says this bin is empty. It has no property because it has no get method except the get class. So what can we do? Of course, we could create the getter. In Scala, we could just have these annotation bin properties. And what can we do for records? We can temporarily, I believe, or I hope, use this JSON property as well. And now when we run it, you see it got serialized. So this might be a little gotcha in all these libraries and frameworks which are expecting your objects to follow or obey Java Bean convention. So they basically have getters and setters. Of course, your record won't have setters, but it also doesn't work in Jackson right away, at least currently, because it doesn't have getters. So you either add this JSON property for now, or in one of the future releases, I hope, Jackson is going to recognize that what you're trying to serialize is actually a record. So it should use accessors, not getters, and that it should go, as I have shown you, this way. So they test it whether it's a record, and then they get record components and so on and so on. The same for GPA and other stuff. So for time being, if you're really eager, I think one of the options is to use a JSON property, and I think it's better than to use it to create custom getters. Yeah, we also have this reflective examination in here. So if you're really interested, so you can see that, what's annotated by class JSON property now. So you can see that in this bean, I have annotated this accessor-like method. This method is annotated. I can also annotate this field, so I have it in two places. And then you see I have this field and this method annotated. And when you do that for the record, just here with this record component, this annotation is kind of copied or inlined or present or whatever we call it, also in field and in the accessor. So this is how it works. And as for nesting, because nesting is also possible, yeah, one thing about Java reflection, I believe Sergey is going to hate me, but maybe not. Yeah, when you're trying to use reflection, please make sure it really fits your needs, because it de facto violates object-oriented programming and so on. So please don't abuse stuff by overusing reflection just because you can. So let's go back to nesting at records, and nesting records is possible. So nested records behave just like static class, so they don't keep the state of the class or the object they're nested in. And they are very handy also for streams, reduce, and collectors. Let me show you what I mean. Yeah, see, I can have this. I have a class and closing class, and I have this nested record, and I can create a. Yeah, it behaves basically like this, and I'm not sure if there's much more to add in here. Just you can nest records in classes. Of course, you can, if you keep it as a top level class, it needs to match the name of the file. I mean, no exceptions here as far as I can tell, but they are really handy because you can also nest them in methods. You see, this is one of the examples I was showing for Java 12 for team collectors. So previously I had this long class with fields and constructor and to string, and now I don't have to. I don't need this boilerplate code. All I need is this line, this single line, and this example keeps working. So see, it's still working. So records are really nice fit if you have, I don't know, like DTOs or value objects or things like that, which don't mutate, which don't change over time. I think we might have some questions over records, so let's go through helpful null pointer exceptions. In the meantime, many people were saying that right now Java won't have null pointer exceptions and stuff because they saw it somewhere in changelog. It's not the case. We still have null pointer exceptions, unfortunately, but we have a new standard feature introduced in Java 14 in this JAB 358, which is about making the messages to null pointer exceptions more helpful. So when you see a code like this, see we have like a few objects nested, one in another, and everything is fine here, and then we do something to A, and of course all of them are mutable, and we get null pointer exception in this line. Can you tell me what is null here? Like, is it A or is it D, or maybe it's fin, or we don't know. And when we see that in a log, you also don't know. You need to recreate this example and reproduce this back and to see what was null. And now we can use null pointer exceptions. Yeah, this is the message basically, null pointer exception, and it says that in this line somewhere there is a null. So we can keep guessing it's somewhere in here, but that's pretty much everything we can do. We don't know what exactly is the null. Actually, helpful null pointer exceptions are about messages which are trying to say what cannot be done and why it cannot be done, and of course where, because we have this line, and they are describing the consumer of the null, not the producer. So they won't tell you in which line null was stored. It will just tell you that when you try to consume it, this exact thing is null, and that's why, for example, you can't access a field, you can't set a field and stuff like this. This message is not serialized, so if you're still using EJBs or something like this, on the other end of the wire, you're not going to see what caused, what was null. And they are computed on demand, which is quite okay in terms of performance. I mean, if you're not going to get message, they're not going to be calculated, or this algorithm trying to generate this helpful null pointer message is not going to be executed. And they controlled by this parameter. So we have to add $X and then plus show code details in exception messages. Yeah, so let's go back to code and let me show it to you. Yeah, we have this null messages. Okay, let's run this code. Sorry. See, and this is the default behavior. We just see null pointer exception, null pointer exception, null pointer exception, and that's it. And this is the line. And of course, here we see that it's E that was null, but I could hide it in a, in a message, in a method. I could just have received that or whatever. So in this example, it's that simple what caused this to throw null pointer exception, but it's not always the case. Like maybe in here, if you need to spot that you are getting bar, which was not in this map, and then that's why you cannot call length on this null, because this will give you not optional, but it will give you a null. So what you can do about this is that we can copy this and go to edit configurations, and as VM options we can add this plus, because for now they're hidden by default, and we can run it again. And now you see these messages. Cannot read field F because ABCDE is null, like in this line. So now you don't need to recreate this example. You know why it is null, why it doesn't work. I mean, you don't say this message doesn't say that it's set in line 36 that it is null, but it says that in line 37 you cannot consume this or run this because this E is a null. And you see, there are more like this. Cannot assign field F because this is null. We cannot invoke string length because the return value of Java util hash map get object is null. So this algorithm is trying to be pretty much descriptive. You cannot load from array because int array is null in here because we didn't initialize this array. Or you cannot store to object array because int array is null, like in line 50, which is this, I believe. Yeah. I mean, even IntelliJ is clever enough, so it makes this orangish background. But let's say we have this disabled, or you just browsing the code in Vim because why not, or in GitHub. Now we can see why it doesn't work. Or another array at index 1 is null, or cannot load from object array because another array is null and stuff. One thing, when you just throw a null pointer exception on purpose, of course it won't have this message, so nothing changes here. It's still the same. Yeah, and these are these classes, see, so they are pretty dumb, nothing fancy here. Okay, so let's jump to Java Flight Recorder event streaming.
Okay, so Piotrek, so if you end this part,
question.
so there is a question, yes, about records. Okay, so is there any hidden agenda behind records, or is it just more consistent way to write value objects? Are there any cases where it's really recommended to use record instead of podrop plus lambok?
It's this thread again. Yeah, I mean, recently, and because I'm like watching Java 14 records on Twitter pretty intensively, I would say there's always this debate whether what should we do, and there are different let's say parties arguing or even fighting with each other. Some are like pro Lombok, some are totally against Lombok, some say that we should do everything as records, and some even say we should use Scala and so on. So what's the agenda? I don't know the agenda. I think, I mean, we can go back to this link of records because why not? I mean, the JEP. And it does it very nicely, I think. We should have it, sorry. Yeah, this link. Let's open this link. And see, it's a common complaint that Java is too verbose or it has too much ceremony. So this is basically it. When you just need a value object, a thing that doesn't have any moving parts, you need to create the fields, getters or accessors now, toString, hash code, and equals. So a lot of people are doing that with value annotation from Lombok, but then there are some drawbacks of Lombok. I mean, if you add another field, it gets magically, or of course dynamically during compilation, these methods like hash code and equals and toString get overridden. So you don't need to remember that, oops, I need to regenerate this in my IDE. So that's one thing. But then, for example, this cross operation with Scala, if you have a single build, is not quite okay because Scala compiler doesn't recognize compiler plugins. And Lombok is de facto a compiler plugin. You need to have a plugin in your IDE to see the code working properly and so on. So I don't know any hidden agenda. I don't want to get into this war. What's best for you? What I would say to everyone is just maybe it's worth considering that you don't need like beans with setters. So for time being, I don't see much difference between Java beans, where all the fields are final, and records. I mean, they are more or less interchangeable, except that we don't have getters and records, but accessors. And you're almost guaranteed that equals and hash code is going to be okay. But then you need to remember that, for example, you can't keep a set in the record and so on. So I think before getting into this debate, you should really read and understand how to implement equals and hash code. And that's the key aspect of this whole flame war, basically. I hope that answers the question. If not, I can we can have another flame war on Twitter. Why not? I mean, this asynchronous stuff is pretty tough, right? I've never done a presentation like this, so I hope you guys are still not blaming me too much. Okay, for events, come on, maybe like this. Yeah, so there's another standard feature in Java as JET 349, and it's about event streaming. Because I don't know if you have ever used Java Flight Recorder and, let's say, Java Mission Control. If you haven't, you should definitely try it. But it has already had one drawback up to today. Like, you could record a file, like a segment, let's say 1 minute, or you can analyze it post-mortem when your Java process died. And then you can analyze, so we had such an event and led to something else, and so on and so on. But we weren't able to do that in real time or near real time. And Java Flight Recorder can now stream these events, so we can consume them in near real time. And that's the point in this chat. Yeah, so it's an API for consuming JFR events in near real time, and it's possible in process, so we can do it like explicitly in your program that you're going to consume these events, and you can do it also as an agent. For example, if you're running somebody else's code but you like to have the in process kind of embedded, sorry, not embedded, but the in process in the same JVM process, analyzing or reacting to this event streaming. Or you can do it out of the process and then keep reading it from streams. So you tell your Java process to dump these JFR events to a disk, and you can have another process consuming it from disk. Yeah, let's run a short demo, because we have a demo, right, for Java Flight Recorder events. Yeah, so I have a garbage generator, and please, folks, don't generate garbage. I mean, you know, being eco-friendly is not about segregating your garbage, but it's about not generating garbage, I think, in the first place. Anyway, we have a simple garbage generator, and what does it do? It waits until ready, and then it uses some memory and CPU. So let me run it first. Let me run it. Yeah, and I need to enter when ready. I'm entering empty, and now it's going to generate garbage to consume memory and CPU. Maybe you can see here, you know, in this CPU and memory consumption grow up. And maybe I'd like to, you know, be able to react to these events emitted by Java Flight Recorder. So I can do it like this. I can do it internally. I can embed it in my program, in my process, and it's actually quite simple. So yeah, I can read all the JFR configurations available like this. Then I can load the default one. I'm just, you know, doing some printouts so we can see the parameters and stuff. And then I have this monitoring for events in another class in here. And I'm monitoring, so I get I have the supplier of event stream, and on this event stream, I have this event stream, and I register event handlers. So these are the handlers I'm registering. So I want to do something where when I receive the event on garbage collection. Sorry, I didn't stop this. No, I did. So the only thing I do is just I'm printing this out, but you can do pretty much everything. You can log it, I don't know, with like SLF4J. You can notify an external system, and you can do, you know, whatever you wish to. Let's say, for example, if CPU load is above 70%, you know, or any other limit, you want to do something, I don't know, send an email or whatever. You can just do that. I'm just printing this out. So let's run it again. All right, and I need to press enter, and now I see it. So now we see this is this configuration being printed out. So we have two configuration, profile, and default, and these are the settings of this default configuration. And now, yeah, when events are emitted, I'm consuming them. So you see this is a GC heap summary. So it started, and this is the ID, and this is the the state of the heap space and the heap used, and so on. I have this metaspace summary. For example, I have this garbage collection. I have JVM information. I have CPU load and stuff. I mean, whatever I subscribed in this monitoring, and it keeps growing. See, now I'm almost run of the physical memory. It was somewhere in here. I mean, it's still emitted. So see, now it's 29.4 gigabytes and so on. So I can do something. I don't need to stop recording to analyze the events of GFR in a kind of offline mode or totally asynchronous. Now I can do it in near real time in the process. But let's say you can't do that in the process. Let's make sure it's stopped. So you can run it, for example, as a monitoring agent this way. So you can take this example. We can MVN package it. Where's the terminal? Here's the terminal. Where am I? Okay. Yeah, we are here. So I can MVN package, and of course I have this is like it has this pre-main. So this is the Java agent, and it's also written in this manifest file. So it has this this pre-main class and so on. So once I have it, sorry, let's go back to this monitoring agent. I can run the garbage collector with this parameter. Let's copy that, and this garbage generator, and here edit and VM options, and I'm going to run this, and see I don't have this internal monitoring running now. It's commented out, so it's not going to work. So let's run this, and see, it's working. So I didn't have to touch this code. I was just able to create an external monitoring agent, and now I'm running it in the same process. See, I have just one process garbage generating running. It's kind of, I injected this monitoring using an agent. So this is one way to do that. But the other way, let's say you're not even allowed to start it with an agent because of security policy and stuff. You can do also you can do that in another way. Yeah. So we could use you can start your process with this these options, for example, or even if you didn't start it, you can do that on demand. So let's go back here. Let's try to run it, because why not? I mean, it's demoing. What can go wrong? We're separated physically, so you're not able to throw anything at me. So it's safer this way, I believe. Okay, so. Yeah, let's run this garbage generator then. Yeah, see, it's running here. So let's go to, let's copy this and let's paste it, and let's run it. See, it started Java Flight Recorder. And now we can tell it, I mean, we can configure the Java Flight Recorder to emit the events to this directory, tmp/jfr events / there will be another directory, you'll see. Yeah, so this is this repository path. You see my terminal is black by default, so don't worry about my eyes fault. but thanks for caring. And I can have now this external JFR monitor. So see, I can paste this path and let me run it. And let's see what happens. So here as debug, I have this garbage collector. So now we are generating garbage, and here we are running it, and we see the stats or stuff emitted by that. Sorry, we saw before because this process ended or something, or it wasn't running it and stopped, like something like this. Anyway, this is the way to do that using. I mean, you can try playing with this. With this stuff, I added these comments here to make it a bit simpler. So you can either start flight recorder immediately like this, or when your process is running, you can do it like this to start recording, and then to configure repository path, and then this external monitor. You either know the path, or you can grab for this path like this using jinfo command. So that's pretty much it. I mean, instead of dumping this file and doing that in offline mode, you can now react to events emitted by Java Flight Recorder in near real time. Foreign Memory Access API, it's an incubator module introduced in Java 14. And it's about avoiding limitations of byte buffers, because byte buffers are indexed by integers, as far as I remember. So if you have like a, in-memory database or something, you're limited by this. And also to be safer than SunMISC unsafe. So they wanted to create something in between. So it's as easy as safe as byte buffer, and it could replace SunMISC unsafe, which shouldn't be used because it's unsafe. Remember, even the class name says unsafe. And of course, it should perform equally well. I mean, in terms of CPU and stuff. So I should have it as well. Yeah, it's not my code. I just kind of copy and enhance it from the JEP file. Sorry, JEP page. So as you can see, we can have this. Because what they also allow in this foreign memory access API is that we can have very nice layouts of our memory. So I can have memory layouts that I can have 100 integers basically, and I created a var handle. Remember var handles like Java 9, I believe. And then in this memory segment, in a try with resources, I can allocate natively in memory, I mean, of the heap, that many elements, which is 100, and then I can read them. So it's not rocket science, but I'm not creating a error. Oh, yeah, it doesn't work. Why it doesn't work? Because we need to add modules. Add modules. JDK incubator foreign. If I'm doing that correctly, let's give it a spin again. Sorry, not that module, but I have this module in POM. Maybe I made a typo. So let's see again. Whoops. Okay. Edit configurations, add modules. Yeah, typo. See, so I was able to allocate 100 integers in a native memory of my program. So I'm not creating a in-memory database or trying to avoid garbage collector and so on. But in case you're in such need, now it's possible with this incubator module. So this is the way to add incubator modules. See as compiler arguments, I put it add modules and this JDK incubator foreign. And when you're trying to run it in IDE, you should also have this. And when you're trying to compile it, let's see, settings. And there should be compiler. No, it's not this. Where is Java? sorry, it should be like Java compiler. Let's maybe like Java compiler. Yeah. See, I also had to add it here, also for the compiler, because else this code cannot be compiled in IntelliJ. So if you're trying to run it at home, please make sure you add it here, and you also add it to your run configuration. And I spoiled something here. Okay. So back to the presentation, packaging tool. So many people, just like me, need to deliver or distribute their programs, like say as debs for Debian systems or Debian-derived systems, RPMs for Red Hat systems, MSI for Windows, and so on and so on. So now it's a packaging tool, which is incubator module as well. It got introduced in Java 14, and it allows you to building kind of a native, I call it native packages, I don't know a better description, for different platforms. Thing is, for each platform, you need to use the system or this packaging tool at that platform, meaning you can't create a Windows installer with like on Ubuntu. It's impossible. And it doesn't have any GUI, it's a CLI only. So how to do that? It's in README file. I mean, it took pretty much long, so I'm not sure we're going to do that, but this is what you do. You can go to MVN, so we had MVN package, then you go to target, then you copy the artifact to lib directory, and then you call jpackage, you name it dd, and as input you put this library directory, which should have all these dependencies. Do I have this lib directory somewhere in here? In target lib. See, I have this Jackson libraries here, and then this is the name of this file. So okay, it should be quite simple. So let's do that. So you see, I'm not cheating. Target, and let's copy the artifact because we should have packaged that before. So now tree-lib looks like this. See, we also have the main jar, and we have all the dependencies in separate jars. And now we can call the jpackage. Yeah, it says it's using incubator module. I'll try to raise it a bit. And what it should do after a minute of waiting, or maybe not that long, let's see. Yeah, it finished, but what did it do? It created this deb file for AMD 64. You see, because I'm running Ubuntu on AMD 64, it created this deb file. So now I could upload it to my apt repository, or I can send it to another person, and they could apt install it basically and run it. So this is it about this jpackage demo. Okay, non-volatile map byte buffers also introduced Java 14. And these are about kind of a native access to NVMe devices, but only on Linux 64 and this architecture, because these architectures have proper instructions in their CPUs, and it's only going to work on Linux. Sorry, I'm not managing I'm not working with any non-volatile memory devices in a way that I would need a native support, so I can't describe it more for you, but you have the JEP. If you have such need, you're more than welcome to do that. Two more JEPs. ZGC got ported to macOS and to Windows, so apparently somebody is running really huge hits with macOS and Windows. I didn't know that, but still, it seems that now it's possible with Java 14. And Solaris and Spark ports are deprecated with the intention that they are not going to be created in the future as a result of this JEP. And also this combination of parallel scavenge and serial OGC, it got deprecated. So in the future, it won't work, and it's because it's rarely used, and many people, but it's still quite a significant headache for the maintainers of Java. That's why. Yeah. CMS finally got removed, so there is no more CMS in Java 14. So now when you try to run something with CMS, it will simply, I'm looking for this switch, but it's not here. Anyway, it won't run. Sorry, I messed the JEP number. No, it's the same, or maybe I messed it. Yeah, sorry, I missed the JEP numbers. I fixed the slides. It's a different number. Anyway, it's not going to work now. It will just start using default, which is G1. And this pack 200 tools and API also got removed because we are not using 56 key modems anymore. That's why these tools got removed, and we have the J package as I have shown you, so they are not needed. Yeah, and there are more changes introduced to Java 14. I mean, there are really more. You can grab the release notes, and some of them like this, like thread interrupted is always available, and thread suspend and thread resume are deprecated for removal. Let me show you them. So yeah, it's not this one. It's, let's go here, and yeah, I have this thread changes. See? So when you still have a code like this, you see this red line, which means deprecated for removal. Now it has this for removal. So if you still have these methods like resume and suspend in your code base, it might be that they won't work or compile in Java 15, and they won't run in Java 15 or any other version beyond. And the thing about this thread changes is that, for example, now you can interrupt a thread which is not running. See, I'm not starting this thread, yet when I run it now, it says that this thread is not interrupted. Of course, it's not running. Then I'm interrupting the not running thread. I mean, it's not started and it's not finished. And then when I check the interrupted, this flag is preserved. Previously, there was a guarantee it will be kept for running for live threads, not for every thread. Now every thread records the interruption, so we can just query if it is interrupted, if it's interrupted or not, at any time, basically in the life cycle. There's a number of updates to Shenandoah, Epsilon, and Perl garbage collectors. Yeah, now when we have a DNS query using TCP, not only UDP but TCP, there is a socket timeout. Of course, there are changes to root certificates, to Java security, and so on. I mean, stuff got obfuscated. I mean, the outdated certificates and so on. There is also an update to formatting of currencies, numbers, and IP addresses, IPv6 addresses, I believe. And now CDS runtime class path validation is more forgiving. So if you're running a CDS archive generation and some files are missing, it's not going to blow. It's just going to skip them. And there are many more updates. So maybe you should read these release notes. Yeah, quoting Mr. Mark Reinhold, thanks to everyone who contributed to Java 14, to every version of Java 14. And really, I have this feeling because everyone was afraid that, you know, with these 6-month releases, Java is going to have small releases. I mean, I'm sorry, but from my point of view, the number of changes and possible impact of the changes introduced in Java 14 is way beyond what we saw in some, you know, major Java versions in the past. So it's not that these 6-month release versions are always going to be small. Sometimes they might be huge, in fact. Okay, folks, remember this always, and everyone give feedback. We are not a conference. We are not seeing each other live, sadly, but what can we do? We can stay home and stay safe. But please give me a short note what you think about this. Also, it's a new experience for me. I wasn't doing this much in the past. So there is a form. You can go, you can click this link, and it will open a short anonymous survey if you'd like to be anonymous. If not, you can DM me on Twitter, on Telegram, for example. So I think this is it. These are the slides, and this is the code. Yeah, and this is the code again. Sebastian, do we have any more questions?
No, we do not have. We just have one request. Could you please share a demo and code after presentation?
Yeah, I just did. I mean, I did it even before. So see, you have a link to slides. So the slides are slides are on the internet. Also the code. So if there's nothing more, I'm sorry it took so much, but see, I was pretty fast still. This release is pretty huge. I mean, we had with this release 16 jabs. So even if some of them are pretty, let's say, simple, like deprecation or ZGC or Mac OS and Windows, I mean, simple to describe, they are still huge changes to Java. And I really hope that the thing that was started with Java 8, I mean lambdas and streams, will continue now with records, switch expressions, and with this pattern matching, because this would mean that in Java we can create not only object-oriented and imperative code, but we can go more functional and declarative in style with immutable data structures. And I think this makes Java really adapting to a modern world, basically, because let's remember that Java will celebrate in May 25 years of its existence since it was published. I mean, the version 1.0. So for the language living so long and still introducing new features, I think it's a pretty decent result. And that's why the architects cannot throw everything we'd like to have instantly, because they try to keep, some backward compatibility. So one last thing, if you have some ideas or you have some feedback after using these preview features, please let the authors, the architects of Java know, so they can fix it in future releases. So Sebastian, is that all?
Yes, I can only thank you for this talk, and thank you all for coming.
Yeah, thanks everyone for joining us, and remember, folks, stay safe and stay sound. Thank you very much, and see you next time. I think in next week we're going to have another streaming, right? Or 2 weeks, something like this, with Margarita.
Yes, exactly, 26th of the March.
Yeah, so subscribe to Wrocław Java user group. It's going to be in English as well. Thank you very much. Good night and good luck.